we are improving day to day since its inception last 10 plus years. Placements and higher studies and R&D also introduced, and the department has got now more than 12 to 15 lakhs worth R&D projects from RCI, DRDO and Unnata Bharat Abhiyan and Smart India Hackathon, etc. So department has as on today 23 faculty members, in which there are 3 professors and 4 associate professors, and 16 assistant professors are there, with 6 plus 1 supporting staff and 2 ministerial staff. So department is having to meet the demand of present day in terms of hackathons, as well as national as well as semi-international conferences, and so many IEEE workshops and value-added courses also have been imparted to educate our students as well as stakeholder to get outcome more than 85%. So this is in brief about EC department. Now I invite one of our faculty member who is in charge for this webinar, and other ambassadors also, including EC department faculty, both teaching and non-teaching, and other professors from other engineering departments of Matrusri Engineering College. I welcome you all to participate in this and effectively discuss various doubts with our speaker. Now over to Kunda Praveen to read out the biodata of our speaker. Thank you.
Thank you, sir. Good morning to HOD, today's speaker, and my colleagues. Good morning, everyone. A warm welcome. And today's speaker is Kushal Nesarkar, sir. He is working as embedded system engineer in the organization Edgate Technologies Private Limited, which is located at Bangalore. He is working since 2019 till date. Sir has a working profile like working as an embedded system engineer, having experience with embedded software, hardware, microcontrollers, DSP and Texas Instruments softwares. Sir had working experience, worked on Texas Instruments. He worked on 16 and 32-bit microcontrollers, digital signal processor and ARM architectures. He experienced with the Texas Instruments, Code Composer Studio, Energia IDE, and also worked on embedded communication protocols, Texas Instruments real-time operating instruments. He has worked on digital signal processor from Texas Instruments C6748 and C6713, and conducted webinars on embedded system and Internet of Things. And he also conducted off-campus and online trainings in the field of embedded system communication protocols, real-time operating system and Internet of Things. He has trained 2,000 plus students and faculties under the training programs in various fields, which organized in various fields. Recently conducted training programs at PDA College of Engineering, Gulbarga, Dr. AIT Institute of Technology, Bangalore, ACS College of Engineering, Bangalore, and Digital University, Kerala, etc. Various training programs has been organized by them. Sir has handled several projects under wireless communication technology, research development on communication protocol using TI 32-bit microcontroller, memory units, IoT based smart systems. And he has education qualification, completed Bachelor of Engineering degree from Jain College of Engineering, Belgaum, Karnataka. This is a brief profile about the speaker today, and conducted various training programs, as well as conducted various webinars, etc. So I welcome Kushal Nesarkar sir again to please hand over the session.
Yes, thank you, sir.
Thank you, sir.
Yeah, first of all, I hope I am audible for everyone.
Yes, sir, you are audible.
Okay. I think you need to give me the permission to share the
Yes,
screen.
sir. Now you can share the screen, sir. We have stopped the sharing.
Okay.
Sorry, guys.
Yeah, I hope my screen is also visible for everyone. So once do confirm in the chat box, or you can just take off your mic and you can just confirm me.
Yes, sir, it is visible.
Okay, fine. Thank you. So, like as we know, we are here gathered to discuss regarding the embedded system and IoT. So here are my outlines. Like you can say, I'll just be starting with an embedded systems, and we know that there are various booming technologies which are coming up. So there are various different kinds of you can say industrial revolutions and all. So we'll be discussing. I'll be discussing about one of the latest technologies and which are the necessary one. And here we are lying in the industrial revolution. You can say 4.0, where one technology is dependent on other technologies. So I'll be just starting with an embedded systems. Then we will understand a brief about the embedded system. What is this embedded system? What are the applications of embedded system? Then characteristics of embedded system. Okay. Then how we can use the embedded system into various technologies like you can say Intel IoT, and how we can implement this IoT for the artificial intelligence and all. Okay, so these are the technologies which are booming up in the industrial revolution 4.0. So once I complete the introduction to embedded system and all, so I'll be just starting with what is Internet of Thing. What are the elements of you can say Internet of a Thing? What are the future trends of Internet of Things and all? And at last I'll be introducing at gate based IoT for you kids, so where you can do IoT applications on the particular board, and one demonstration I'll be just showing with the particular board as well. So this is my today's outline. Yeah, so as you know that there are various industrial revolution which we have gone through. Okay, so when we talk about the industrial revolution 1.0, so which was invented you can say in the year or you can say in the 18th century. And here industrial revolution 1.0 you can say it is completely of mechanizations, where all the equipments were mainly focusing upon the mechanical energy, or can say steam engines. Okay, so let me give an example for the industrial revolution 1.0. So we have the steam engine train. Okay, so then for the transportation we have steam engine trains. Then we have the boats as well, or you can say the ship, which was in the earlier days you can say it was running on the mechanical energies. So this was happening in the industrial revolution 1.0. And in the 19th century you can say at the end of 19th century the industrial revolution 2.0 started, where the focus was on you can say the mass production. Okay, to for the mass production you can say there were many employees were required. But here what was happened is there was conveyor belts were introduced, and with the help of the conveyor belts the mass production was happening. And most of the time you can say at present also this particular technology is being used. And we are not leaving the technologies or industrial revolution behind only, but we are utilizing the industrial revolution 1.0 you can say 2.0 you can say in the better way, in the you can say the smarter way we are using as the in the industrial revolution 4.0. And in the industrial revolution 2.0 you can say most of the time it was based upon the electrical energy, and industrial revolution 1.0 was based upon the mechanical energy you can say. Then coming for the industrial revolution 3.0, you can say it is completely based upon you can say electrical one, or you can say automation kind of a thing. So here what was happening is you can say this is the era of electrical, where uh, PLCs were introduced. Okay, then we where we were able to control the huge machineries with the help of PLCs. And here, one thing is in the Industrial Revolution 3.0, so the programmer has to sit in front of a particular machine to control any other machine, you can say. Now, let us take an example. So there is a hydraulic pump, okay, which is you can say which is having that sizes you can say 1 ton or 2 tons or 100 tons. Okay, to control that particular hydraulic pump. Okay, so it's manually it's highly impossible. Okay, so here you can say with the help of electrical PLC based system, the machines were used to control. And here the programmer has to configure if he need to do a smaller changes, something like that. Okay, so that was industrial revolution 3.0. And in the industrial revolution 4.0 you can say we came up with embedded systems. And as the embedded system was, is in the booming like booming up. And after that, we have came up with the Internet of Things. Okay, so after that, we have come up with the artificial intelligence, machine learning, and deep learning. So all these three technologies, you can say, which lies in the Industrial Revolution 4.0. Now let us take an example. Like, I want to start with an, intelligent, sorry, IoT. So if you want to start with an IoT, so there should be some base. Okay, so here you can see the embedded system is a base for IoT, for doing some kind of application like home automation, it may be, or industrial IoT, it may be, or any kind of application if you want to control. So that will be based upon the embedded system kind of applications, or can say. And here, in Industrial Revolution 4.0, cyber security also plays very much important role. Again, it is one of the booming technology, you can say. So this all the technologies lies in the Industrial Revolution 4.0. On the basis of this Industrial Revolution 4.0, I'll be discussing about embedded system, IoT, and future trends of IoT. So, as we know, when we talk about an embedded system, okay, so generally we are, surrounded with so many computers around us. Okay, basically there are two types of computers, you can say. One is the general purpose computer, another is the embedded computer, or you can say embedded system. Now, when we talk about the general purpose system, so we know, like, we have the, you can say your desktop or your laptops are nothing but a general purpose system. And in the earlier days, you can say this general purpose system are mainly used for, multitasking kind of applications. And most of the time, whatever the job is given for a general purpose system, that will be done. Okay, but now when you talk about the implementation kind of a thing, okay, now later onwards, you can see the embedded system were introduced, where similar kind of a functionality the smaller machine used to do. But here there was a small change in this, general purpose system and, embedded system. So I'll be just discussing about this general purpose system and embedded system in a few minutes. So here, embedded system, you can say, is nothing but a one system where everything is been integrated with each other. And when we talk about a system, it is nothing but it need to follow some or other rule. Okay, and you can see there are different definitions according to the developers. Okay, about the embedded system, or it may be an IoT or artificial intelligence. Okay, so here I have taken a small, you can see the definition to understand the general, you can say, embedded system. That is nothing but embedded system is nothing but a combination of an hardware and a software design to perform a dedicated function within a larger mechanical or a electrical system. So it's like, you can say, when you talk about general purpose system, it is a separate system. But an embedded system is not a complete system, or you can say not a huge system, or it is not a smaller system. It will be the part of other system. Okay, if you take an example of any electrical devices, or you can say take an example of your vehicle. So in vehicle also we are having, several embedded system which will be controlling some kind of applications, or which will be controlling some kind of a peripherals. So such kind of a devices or such kind of a systems are called as an embedded system. So here the main part of an embedded system is nothing but a core part. Okay, because core is something like CPU, which can handle all the things, which can handle the input devices, which can handle the output devices depending upon the requirement. Okay, now when we talk about the core, so here there are different kinds of a core, you can say. If you talk about the microcontrollers, you can say microcontroller is a core unit. Then you can take example of microprocessor, FPGA, AC, AIC, AC, AISC. Okay, so there are different kind of a system, digital DSP, you can say, digital processing system. So these are called as a core units, you can say. And whatever the inputs which we are attaching, so those will become as an input part, and whichever we are taking as output, those will become as an output modules, or can say output peripherals. So when we talk about the input devices now, and we know that we are surrounded with embedded world. Okay, now take an example of your mobile phone. You can say mobile phone lies between somewhere around, you can say, general purpose system and embedded system. Okay, now take an example of your AC. So AC, you can say it is an part of an embedded system, or you can say embedded system is a part of an your AC. Okay, like this devices are there. So here sensors can be the input devices. Then you can say uh, keypads. Okay, then you can take examples of, some kind of sensors or solenoids. Such kind of a devices become as an input. And we know that what are the output devices for whatever we are viewing in our day-to-day life. You can say the monitor is an output devices. Then you can say display devices. Then some kind of motors. So these are some, you can say, some of the output devices. Now, to understand the embedded system in the better way, so the best thing is we need to understand the characteristics of an embedded system. So then only we can understand a proper embedded system. So when we talk about the first characteristic, that is the task specific. Okay, now as I already discussed, I'll be discussing about general purpose system as well as the embedded system. So in this particular topic, or you can say in this particular characteristics, I'll be just discussing or comparing both embedded systems as well as you can say general purpose system. So the first characteristics is like a task specific. Okay, now if I give one task, okay, let us take an example of your microwave oven. Okay, now I'll just, I want to bake some cookies. Okay, now I'll be keeping the cookies into the microwave oven, and I'll be just, setting up one time. Okay, let us take an example. I want to bake my cookies for 10 minutes. Okay, now what will happen? A system, which is can say embedded system, which is going to bake the cookies only for 10 minutes. So it will not take more than 10 minutes. So once the 10 minutes is completed, so the system is going to off. Okay, automatically the system is going to off. So here this is called as a task specific. So whatever one task is given for a system, it will do only one task. Now if I take an example of washing machine also, and if I want to bake the cookies into the washing machine, so that may not be work. Okay, because that task is unknown for that particular machine. So this is the meaning of a task specific. And time specific, we have, again embedded system is classified into different types, you can say. Hard real time systems, then soft real time systems will come, where you can say hard real time systems are nothing but a system which need to perform a task in a dedicated time. 10 minutes means it should do a task within 10 minutes only. It should not take more than 1 second or less than 1 second or microsecond also you can consider. Okay, so if you talk about the hard real time systems, then you can take examples of, sonar system, radar systems, or the devices which are implemented or used inside the, aeroplanes or the fighter jets and all. Okay, such kind of devices which are implemented in this particular kind of systems, you can say it's like hard real time system, because here the system should not miss a deadline. Okay, and the soft real time system or soft system, you can say, you can take an example of your DVD player. Okay, you can take example of your DVD player. If a deadline misses also, there is no huge losses in this particular kind of a system, so which you can classify into in a soft real time systems. Okay, I hope time task specific and time specific is clear. And here we have something called as minimal user interface. So when we talk about the minimal user interface, and nowadays, like, developers are trying to reduce the interface. That is nothing but a user interface. So here in embedded system, we are trying to, reduce the maximum user interface. What will happen is, like, when we are trying to interface maximum interface or maximum user applications, what will happen? You can see the system complexity will increase. First thing is system complexity will increases. And if you are using a device which is having the less, input output devices, then again we need to change the controllers, or we need to change the device. So for that and all, again you can see the cost, everything will be varied, all the parameters will be changed. So here minimal user interface or no user interface kind of a system we are doing here in embedded system. Then all the embedded system, you can say, provide us good efficiency, good reliability once we buy a particular embedded systems and all. And one more good point about embedded system, it's is like, it reacts to an external stimuli. So when you talk about this particular characteristics, it's like, you can say, we are dealing with, various kind of environmental changes, you can say, or then like the different kind of signals, you can say. And okay, it may be your temperature, humidity. Okay, such kind of signals our embedded system can react. Okay, you can take an example for this external stimuli is nothing but your AC. So in your AC, we are having the temperature sensors, correct? So what it is going to do, it is going to monitor the room temperature, and depending upon the room temperature only, it is going to execute or it is going to perform its task. Okay, so such kind of embedded system we are having. Okay, then you can take an example of the car as well. In car also we are having, airbag system. How it is going to work based upon the external signals. Okay, once a particular sensor is being activated, airbag system is going to, open. Okay, to avoid the, such conditions. Then first thing is all the embedded system we call it as a Unix system. Okay, now we call microwave oven also an embedded system. Okay, and say the part of microwave oven we call it as an embedded system. Part of your washing machine we call it as an embedded system. Part of your vehicle, okay, we call it as an embedded system. Okay, and why we are calling this Unix system, because one thing is hardware present in one embedded system, so may or may not present in the another embedded system. So it's continuously keep on varying. The hardwares are being varying from one system to another system. So that's why we consider the embedded system as a Unix system. Then here it require less power and low cost. So these two particular characteristics I'll be discussing in my next slide. So to make you understand in a better way. So I hope till this point, if it is clear. If you guys have any kind of queries, you can just interrupt me at any time. Then the next question is like, why do we need an embedded system? So it's like very big question, because I already said like we are having the embedded system, we are having the general purpose system. Both the systems will do the same task. Okay, if I want to measure the temperature sensor, or you can say if I want to control my motor using my general purpose system, so I can do that one with the help of some input and output devices. Same thing I can do with the help of embedded system as well. But why there are two different kind of a systems? Okay, so that will be a very big question. So here I'll be discussing a few parameters on this particular basis. We can decide why we should go for embedded system and why we should not go for a general purpose system. First thing is like dedicated hardware. Okay, now let us take an example. I want to build some model, or you can say I want to work on some particular applications where the hardware is very much important. Okay, let us take an example. I want to build an AC, or I want to build an music system. Okay, so here in the embedded system, we will be selecting a dedicated hardware. Okay, if I want to build a music player, I'll be selecting the display. I'll be selecting some kind of buttons, or can say some kind of switches. Then I'll be using speakers. Okay, because that is the most important part. Okay, if I want to add some sensors, I can add. Okay, that's up to me. That will do depending upon the developer and the customer. Okay, according to the customer, we are going to select the hardware, but it's not same with respect to, you can say, general purpose system. If I talk about a general purpose system, so a particular company, okay, let us take an example. HP company will be manufacturing the laptops, right? So here what they're doing is like they are giving us the monitor they are providing. Okay, they are providing us the a keypad. Okay, they are providing us a mouse. Okay, along with that they are providing some kind of a memory. Okay, so and also they'll be providing us speaker, everything. Okay, but what if I don't want a speaker, or I don't want keypad in my system? So I can't remove that, or I can't tell a particular company that I am not interested in purchasing this particular laptop because I don't want to add music, or sorry, speaker in my system. So whatever it is developed, okay, whatever it is developed, we need to purchase as it is. Okay, we need to purchase as it is. So you can say here no dedicated hardware, or you can say the fixed hardwares are available in the general purpose system. But in embedded system, we can change the hardware according to the user application, or you can say according to the customer. Okay, so that is a very first parameter. Then next is like size limitation. Okay. Now, if you are developing any kind of a product, okay, first thing is we are going to take care about all the parameters, including current, including power consumption, okay, including size limitation, everything. Okay. Now, if I want to develop a one particular product, in that if I'm going to use a general purpose system, the size of my system will be increased, obviously. Okay. But if you are talk about the embedded system, okay, here you can say the size is limited, because here you can say the main thing is the processor size will be very less nowadays. Okay, nowadays there is nanometer technology which is going into processing. Okay, where the size of the processor, or can say size of the semiconductors, are being reduced. If you see the microcontrollers nowadays, so the size of the microcontrollers are very less. Okay, even the small of our fingertip. Okay, so such kind of devices are coming, or can say such kind of processors are coming, and in that, if you see in that particular point, the size limitation is reducing. Then we have the low power consumption. Okay, because when the size of the your processor is reduced, even the low power also will power will also reduce, the power consumption will be also reduced, and which is going to provide you a good effective part for your system. Then real time performance is one of the major factor, because we are living in the world where we want everything on the proper time, everything, okay, depending upon the situations as well. Okay, now if you talk about the general purpose system, so the deadline is not fixed. Okay, deadline is not fixed in the general purpose system. Now let us take an example. I'm just playing some song, or I'm just doing some application in that particular system. So it may do that particular task on time, or it may exceed that particular part. But here in the embedded system, it's not like that, because embedded systems are again classified into two parts. You can say hard real-time systems and soft real-time system. So here we will get good real-time performance as compared to the general purpose system. And overall cost, if you see, of any embedded system, it will be cost effective, you can say low cost, because of dedicated hardware size limitation, then real-time performance and all. So you can say the cost is effective in the general purpose, sorry, in the embedded systems. So if you just see this, that's like I can say, like rather than going for a general purpose system, I will stick for an embedded system. So embedded applications, you can say, are there are various fields. Okay, household, you can say, medical appliances, you can say, or instruments, you can say. Then you can say mobile phones. Then military applications like radar, sonars. Then you can say robotics. Now industries are focusing on the robotics as well. So here the core parts which are going to handle the process, which is be depending upon the controllers, you can say microcontroller, microprocessors, or maybe any other FPGAs, then digital signal processors and all. So all are all the processors or all the controllers comes under, you can say, embedded systems. Then you can say like airplanes, if you see in airplanes also, okay, in toys also, that okay, embedded systems are there. Okay, and there is you can say embedded system will grow, okay, as the other technologies grows, because electronics is one of the department which is not going to come down. Okay, it is like evergreen department, you can say, because whatever the technologies which are future coming, it's based upon the electronics only. Okay, then here one example I've taken, the real time example, you can say the car. Okay, so in this car, so there are several embedded systems. Okay, you can see to control a GPS, we have a GPS module. Then wiper, again it is based upon the, you can say, microcontrollers, you can say. Then ultrasonic sensors are there when you are parking your car. If there is beside one car, okay, it is going to show the distance and all. Then ABS control is there, then to control the headlights. Okay, so everything is depending upon the embedded systems only. And we consider embedded system is not a huge system, and embedded system is not a smaller system. Embedded system is a part of any other system. Okay, whether it is a mechanical system, or whether it is an electrical system, or any other system. Okay, embedded system is a part of it. Okay, just to do some kind of an applications, or some kind of operations. Then we consider embedded heart of your embedded systems is nothing but a microcontroller or a microprocessor, or whichever the devices you take, FPGAs and all. So that is the heart, because the processor is the main part here. So I know, like I hope everyone knows like what is the microcontroller, what is the microcontroller made up of, everything. So I'll be not going in detail about the microcontroller. Okay, first thing is I can tell like microcontroller is uh, mini computer, you can say. So whatever the applications, okay, or whatever the peripherals are available in the normal micro general purpose system, all the specifications will be available in the microcontroller. Okay, so we can consider microcontroller as a mini computer. Okay, because it is having the input devices, it is having the output devices, it is having the CPU, it is having the memory, everything on the chip only. Okay, then when we talk about the microcontrollers, one thing we discuss, that is the when we talk about any system, okay, we'll tell like this particular system is a 4-bit system, 8-bit system, or a 16-bit system. Okay, so it will be that we call it as actually a word length. Okay, from the word length only we will identify a microcontroller and its capability, and what kind of situations, or how a controller can handle the situations. Okay, and nowadays cost of the microcontroller, if you see, hardly it will comes in hundreds. Okay, 100 rupees, or can say 200 rupees and all. Okay, so there is a difference between the microcontroller and the launch pad or the boards. Okay, so when you talk about the microcontroller, it is nothing but the only chip. So whatever you are able to see on the screen, so only this particular part is called as a microcontroller. And if you are able to see this particular chip on any other board, we call it as an development kit, or we consider it as launch pads or target board. Okay, so here microcontroller means like this, and microcontrollers are available in different, you can say, different forms. Okay, like we have DIP, that is nothing but dual inline package, then quad we are having, and so on. Okay, so when you talk about the microcontroller, so these are the basic things the microcontroller consists of. Okay, like we will be having the CPU, then we'll be having some kind of memory. Okay, whether it is a RAM memory or ROM memory. Nowadays, microcontrollers are coming up with something called as a flash memory and double EEPROM memory as well. So that whatever the operations which we can do, so we can utilize all the memories included on the chip only. Okay, then timers are very much important part for the microcontrollers. So without timers, there is nothing you can say, because like to monitor or to can say to generate the delays kind of things for a microcontroller. Okay, that is based upon timers and our real-time applications, which I already discussed. Like we have hard real-time systems and soft real-time system. So the operation is based upon the timers only. So all the microcontrollers, you take any microcontroller, so timer will be available in the microcontrollers. Then serial ports for communications. Okay, whether it can be the any kind of a protocol which is based upon the serial communications. So everything will be available here. Then there will be the bus controls will be there. We'll be having the data bus. Then we'll be having the address bus. Okay, so such kind of a buses are available here. Okay, so this is, you can say, basic diagram of microcontroller, or what microcontroller includes. Okay, so this much at least peripheral will be there. And one more thing is like here we'll be having something called as oscillators. So oscillators plays very much important role, because you can say the heartbeat of our microcontroller is nothing but the clock pulses. The clock pulses are generated by the different kinds of oscillators. So oscillators will also available on the microcontroller, you can say, chips. Okay. Is there any doubt till this part? Just let me know like if any doubts till this part.
It is clear, sir.
Okay, fine. So then there will be one a very big question, like how to choose a microcontroller for embedded application as well as the IoT kind of applications. So this will be a very big question. So first thing is like we need to think about the microcontroller with respect to word length. So word length is nothing but you can say when I talk about 4-bit microcontroller. So my microcontroller can do the operation. You can say 4-bit operation at a time. Now, if I want to do 8-bit operation, so it will take two CPU cycles. Okay, you can say the latency will be increased here. Okay, instead of this, I can go for direct 8-bit operation, or can say 8-bit microcontroller, where it will take only one CPU cycle and the latency will be reduced. Okay, so depending upon what kind of application it is, or how the process need to be followed, what kind of data will be there. Okay, so depending upon that, the word length of the microcontroller will be decided by any embedded engineer or any IoT application engineer. Okay, then next thing is like speed. So speed plays very much important role. So I was also discussing about this heartbeat of a microcontroller is nothing but a clock pulses. So we need to provide a clock pulses. So here the clock pulses is provided with the help of oscillators, and there will be the microcontrollers. And nowadays the microcontrollers are coming in, you can say, the flexible mode, where a user can decide the speed of its microcontroller. Okay, now let us take an example. If I'm having a microcontroller which is having the frequency of 80 megahertz, and I want to do an application or which should run at a faster speed. So I'll be configuring the frequency at a higher speed or the maximum frequency. So the speed of the microcontroller will be increased. If there is any application where the speed doesn't matter for me, okay, that time I can go for the lower speed, or I can go for intermediate speed. Instead of going for 80 megahertz, I'll be configuring it for the 40 megahertz. So whatever the speed which was happening in the 80 megahertz, it will be reduced by 2. So half of that the speed of the my microcontroller will be there. So this is one good point nowadays. Like all the microcontrollers are giving this flexibility. Then we have the packaging. So as I already discussed, like packagings are, we have like dual inline package, or it may be the quad package and so on. Okay, so depending upon your application, or like whether you want to implement that particular microcontroller on some board, then you can select according to it. Okay. Then the power consumption. So here the microcontrollers provide very less power consumption. Then on chip RAM and ROM also available. So depending upon the RAM and ROM, the size, or can say the all the parameters will change. Like maybe whether it is the cost. Okay, so if the RAM and ROMs, if the RAM size is more, the cost of your devices will be increased. If the ROMs, okay, if the RAM size is less, the cost of your device will be reduced. So all the parameters, or can say, will be based upon this kind of peripherals. Then on-chip peripheral requirement. This is very much important point of view. You can say like on-chip peripheral requirement. So on-chip peripherals are nothing but you can say the timer. Okay, then ADC, then PWM, and so on. Okay, now let us take an example. So I have selected a microcontroller. Okay, I have selected a microcontroller which is not having ADC, and I want to interface a sensor. Okay, I want to interface a sensor, but a microcontroller is not having ADC on the chip. Okay, then first thing is it's very difficult to. First thing is not possible to do the conversion for the microcontroller. The analog signal, it will not convert into the discrete signal because there is no analog to digital converter into it. So what I need to do is I need to select an alternate option. Okay, I need to either change the microcontroller, or I need to add the external module. Okay, now if I'm adding an external module, okay, like ADC, so again the cost of your system will increase. Okay, the cost of your system will increase. Again, you need to check the compatibility, everything. Okay, then only you can use it. So to avoid such kind of situations, first you need to decide what is your requirement. Okay, what project you want to do, or what is your requirement, and according to requirement, you need to select a microcontroller which is having all the peripheral on the board. So we need to avoid this one. Okay, we need to try to avoid this particular part, like try to configure an external modules, everything. So which is having onboard everything, so that we can go for it. Okay, so this is very much important part. Then upgradability is also very much important. Okay, because nowadays you can see the microcontrollers which we are available. So here when we talk about general purpose system, we are having the operating system and everything. All the operation will be depending upon the operating system itself. In embedded system, we are having two options. One, we call it as a super loop programming, where the operating system is not involved. Okay, and when we talk about real time applications and all, so operating system is necessary. Okay, now there are various microcontroller. If you see older microcontroller, the operating system which was not supporting, but now there are the microcontrollers, the like operating system are supporting. So whether you want to use the operating system or not, we need to check that upgradability. Okay, if it is available, then it's better. Okay, so like same operation, how the like operating system works in your general purpose system, similar kind of operating system is there for embedded system. We call it as real time operating system. Okay, so that is also one point we need to consider if you are looking for longer period of time. If you want to use that particular product for longer duration, then you need to check the upgradation also. Then cost per unit. So if you are selecting a controller, basically this is the part for an developers, okay, who are selecting the product according to the customer requirement. Okay, so they need to check the budgets as well. Okay, according to the budgets only they need to select the all the hardwares. Then cost per unit also is there. Then check for the availability of the development tools, like you can say assembler is there, compiler is there, or any other IDs are there. Okay, so depending upon this only you can select your microcontroller. Then these are the some skills both embedded as well as IoT engineers needed. So we require C programming, and if you're going for IoT, we have different options. Okay, we'll be having the options of Python will be there. Then embedded C programming will be there. Okay, it's not just a C. We require embedded C programming as well, because there are difference between a C and embedded C. So when we talk about a C, just we are not dealing with any hardwares and all. Okay, and when we talk about embedded C, so we are dealing with some hardware. Okay, now I want to control the lamp. Okay, so a lamp is a hardware device. Okay, I need to control that hardware device with some microcontroller. So I can use the C programming, but not only C, embedded C, so where the hardware pins I need to declare if I want to use a particular pins, everything. Okay, so you can see the combination of C programming as well as the hardware. We call it as a embedded C programming. Then basic electronics is must and should, whether you go for IoT, whether you go for embedded system. Okay, basics of electronics is necessary. Then you need to have a knowledge on how to use embedded hardware as well as the software parts. Then if you are going for higher end kind of applications and all, then embedded protocols are very much important, and networking concepts as important. Because when you talk about like IoT and all, so we'll be discussing about the HTTP protocol, you can see, or the TCP protocol for the wireless communications. So we require this kind of networking concepts. So this is very much important for us. So I have already discussed about the industrial revolution earlier, so I'll just skip this part. Then we'll switch for the Internet of Things. So in the world dominated by, you can see, artificial intelligence, data, okay, and you can see enhancing connectivity, okay, technologies that is okay. It's hard to leave the IoT behind. Okay, because IoT may one of the most important technology, and it's responsible for success of many other technologies, like you can say machine learning, deep learning, and artificial intelligence. We can say these are the future technologies again, which but IoT is very much important part. So again, there are various definitions according to the developers, according to the person, the definitions of IoT, embedded system, artificial intelligence varies. So here I'll just take a small definitions of IoT, and I will try to make you understand. So IoT describes the network of the physical object, okay, that are embedded with some kind of a sensors, then softwares and other technologies for the purpose of connectivity, and you can say exchanging the data with other devices, and a system over the internet. Okay, so here the devices, you can say the physical objects which are integrated with some kind of a network. Okay, and this data which we are generating, or the data which we are accessing from any kind of a sensors or any users, so this data need to be processed. Okay, so for processing you can go for the microcontrollers, or you can go for any other platforms, okay, the cloud platform where the processing of the data is possible. So once it is done, the analyzation also should be done. Okay, so such kind of things, and this data, or this particular devices are able to interact with each other, or can say the exchanging of the information is very much important in the Internet of Things. And all the things are circulated, or the message is conveyed from one device to another device with the help of internet. Okay, and you can say the devices ranging from, you can say, ordinary household objects to sophisticated industrial tools. So everything is possible with the help of Internet of Things. Then there should be question like why we go for an IoT. So as I already discussed, why we go for an embedded system we have understood, but why we should go for IoT. First thing is very much important technology in the 21st century. Okay, which can connect everyday object, okay, via embedded devices. Okay, because if there are no embedded devices, okay, we can't connect any device to the internet. Okay, because for that we require an embedded devices. So here we can connect every object to the internet with the help of, you can say, embedded devices. And by the mean of low computing, the cloud, you can say, the big data, the physical things can share the data and collect the data with the minimal user interaction or intervention, you can say. So without the human intervention, you can say the data will be processed here. Okay, so that is an one of the good point. So why we go for an IoT. And in this hyper connected world, you can say the digital system can record, monitor, and adjust each interaction between the connected devices. Nowadays, there is one more booming technology, you can say, that is um, you can say industrial IoT. Okay, similar kind of the normal IoT which we are having. It is the industrial IoT where machine to machine communication is very much important. So earlier, what used to happen is like, suppose let us take an example. There are two machines, and two machine wants to interact with each other. So initially, there was no you can say embedded devices were there. So a particular system or a particular person or particular engineer has to take the data from one system in some kind of a memory, later feed that data for the another system. So it was consuming much time, and which was not also effective one. Okay, so this thing was happening. Okay, then which came something called as embedded devices, or you can say embedded protocols. So here wired communications were implemented. Okay, with the help of some kind of a serial communications or parallel communications, data from one machine to another machine used to transfer. Okay, so here also, there again, depending upon the various parameter, like electrical parameter, you can say the data communication was not that effective also. Okay, now let us take an example. I'm having a machine, one machine placed, or can say that there are two machines placed at 100-meter distance, then the data loss will happen. Okay, so there are various factors which was happening. Okay, later with the help of IoT, okay, two machines can share the data wirelessly, okay, with a good effective one. Okay, so with the help of some kind of a cloud, the data will be stored from one device to another storage device, and from that it is going to access the data. So here you can see there are various future technologies which are depending upon IoT as well. So I'll be discussing that also. I hope at least you got a basic or brief idea about the IoT. And you can say like growth of IoT is increasing day by day. Okay, now if you see the devices which were connected in the 20th century and now, so there is a huge difference. Okay, and this is the you can say the growth chart which I have taken from one uh, one you can say one page I have taken. Okay, where here it is telling like in the 2014, you can say the 10 million, 10 billion devices were connected, and by 2020 it was around 30 billions, and it has been predicted that like by 2050, okay, more than 100 billions devices will be connected for an internet of a things, or you can say it will be connected for the internet, and which can share the data over it. Okay, so this is one of the prediction which is done. So we'll see what technologies have made IoT possible. Okay. So first thing is access to low cost, low power sensor technologies. One thing is like sensors are become so affordable that like first thing is very less cost is there. Easy to integrate kind of things are available, ready to use. Okay, with the embedded devices. So you can say, and when we talk about the IoT, there are huge kind of a sensors. Okay, take an example of any field. Okay, you can take of your smart watches. Okay, again internally it is having the heartbeat sensors. Okay, so this kind of devices which can collect the data from any kind of body sensor, you can say, or any agriculture sensors, you can say, or any kind of a sensors. So this one thing has been made this IoT possible. And second thing is connectivity. Okay, so as I already discussed about the IoT, sorry, this one, which you can say industrial IoT, that is the connectivity one. So earlier there was no connectivity. Then like you can say when the embedded systems come, the wired communication was started. After that, in the IoT, the wireless communication is being happening. So whether it may be the like with the help of Bluetooth or Wi-Fi or LoRa or any other kind of connectivity. Again, still it is the challenge which we are facing in the industries, the connectivity one. Okay, because we are having a devices which you can say which can communicate for a shorter distance, but for the longer distance, again, it's still the challenge for the IoT. Then we have the cloud computing platform. So as I already said, like when you want to do an IoT and you want to control any device from the world, so you require some device that is called as a storage device, which can store our data. Okay, now let us take an example. We already are using various, clouds, you can say, maybe the Google Cloud or another cloud. So we are storing our information in the Google Drive. Okay, so we don't know exactly at what place the Google Drive, storage devices are available, but we are accessing it from any part of the world. Okay, so that is because of the cloud. Okay, and here the cloud computing platforms are also available where whatever the if you want to apply some kind of algorithm on your data, so nowadays uh, such kind of a platforms are available. Okay, now we know that our microcontroller may not do all the operations. Okay, so we can use our microcontroller for collecting the data and uploading the data to the cloud or pushing the data into the cloud. But what about all the algorithms? Okay, now smart algorithms, you can say, if you are going for artificial intelligence and all. So we have different kinds of algorithm. Okay, so such kind of algorithm we can't implement in the microcontrollers or a microprocessors. Okay, we require the help of some cloud platforms. Okay, whether it may be the big data cloud or any other data cloud. Okay, so that is one of the, you can say, that technology has made the IoT possible. Then, as I discussed, like machine learning and analytics. So if you want to analytic your data, so your microcontrollers and all can't do that one. Okay, that can be done with the help of some kind of a clouds only. Okay, and the you can say the conversational of artificial intelligence is also possible. Okay, has made this IoT possible. And IoT is making, if the IoT has been successful, you can say like other technologies will also become successful. Okay, that is nothing but artificial intelligence, machine learning, and all. Okay. So here I'll just discuss about the basic element of an, you can say, Internet of Things. So first thing is connected devices. So we have various connected devices around us, and most part is here sensors, or you can say the actuators kind of a devices, from where we collect the data or where we control the data. So such kind of a devices we call it as an connected devices. Then central control hardware. So for collecting the data from this kind of connected devices like sensors, actuators, and all. So we require central control hardware like microcontroller, microprocessors, or any other kind of devices like FPGA and all. So we'll be taking the we'll be using this as a central control hardware. And so once the data is being collected, so that will be pushed with the help of some kind of communication protocol or some kind of a wireless communication to the data cloud. So data cloud is also one of the basic, or you can say the main element of your IoT. Then user interfaces are also available nowadays, like you can say I want to control my device using my mobile phone. Okay, so we can control this device with the help of some kind of user interface. I can go for Android applications. I'll create my own Android applications. I'll be connected with the cloud, whichever my microcontroller is using. Okay, so I'll be connecting with that one, and whatever the data is being sent by the microcontroller to the cloud, same thing I can visualize using the user interface. Or if I want to control the hardware, so with the help of the various widgets, I can control it. So user interface is also very much important. And you can say, like in our systems also, earlier days when the computers were invented, that time everything was not user interface. That time everything was, you can say, a command prompt. So if to open a particular file, I need to type a command, and to close a particular file, I need to write a command. But later the graphical user interface came and everything become easier for us. Okay, so here also the user interface is very much important, you can say, for IoT. Then network interconnection is also important. Okay, because we are doing this IoT in the wireless technology, you can say wireless technology. So various network interconnections are required. So I want to connect my device to the Wi-Fi, so everything will be depending upon the wireless communication. So various networking protocols are also necessary, you can say. HTTP protocols are there, then TCP, UDP, MQTT, and all such kind of networking protocols also necessary. System security is one challenge, you can say. We need to secure our data, so that is one big challenge for the IoT applications, because nowadays anyone can hack the data, and you access the data. So system security is one of the, you can say, challenge for IoT. And these are the some key building blocks of an IoT, how the IoT is implemented, or how the IoT is deployed. First thing is we require the smart things. And when we talk about an IoT is nothing but a device, or like an object which can be connected for an internet. The things may be anything. Okay, whether it may be a smart things or whether it may be a non-smart things. Now let us take an example. I want to connect my chair for an internet, but how do I connect my chair? Chair is not a smart device, right? So but we can able to connect the chair to the smart devices. Okay, so we need to use an embedded devices for that one. With the help via embedded devices only, we can make a chair also a smart devices. We can make your water bottle also smart devices, or we can make your bag also a smart devices. Okay, so once a smart devices are ready, okay, we require some kind of a networking protocols where we can connect it for the clouds and all. Okay, so here we require various gateways. You can say we require some NFCs, then Bluetooth, Wi-Fi, LoRa, or any other communication protocols. Okay, so that is necessary here. Then middleware, you can say for data analytics and all. So we require the middlewares like clouds, okay, then big data and all we require here. Then you can say lastly applications. So application may be any device, okay, whether it may be your mobile phone or it may be your web browser or it may be any other hardware. So everything can be anything can be at the application part. Okay, so this is how we are going to these are the basic building blocks, and this is how the IoT will communicate with each other. And there are various IoT benefits also for you can see the for safety purpose, then for society, for monitoring the health, or you can say the smart agriculture, such kind of things we can use for IoT. So there are various benefits for the environment as well to control the pollutions and all. Then for new innovations also you can make use of IoT, okay, and other more. So I'll not take much time, so I'll just discuss a few things regarding the IoT future trends of IoT, and I'll just switch for the demonstration on IoT. So here, when you talk about the IoT future trends in IoT, okay, you can say first thing is IoT connectivity. So still we are facing challenges in connecting the IoT devices over a longer distance. In a shorter distance, we can connect it. Okay, in a shorter distance, we can connect with the various short distance or can say short range connections or connectivity. Like we have the Bluetooth, you can say its range is around 10 meters to 50 meters. You can say so then we'll be having the Wi-Fi or we'll be having the Wi-Fi and all. So its range is not high. Okay, so its range is limited. Okay, and the speed is also limited as the you can say as the distance increases, the bandwidth reduces. And in IoT, you can say the bottleneck of IoT is nothing but you can say this one bandwidth. So without bandwidth we can't transmit the data. Okay, so if the bandwidth is higher, okay, we can send the latency is lower, you can say. Okay, if bandwidth is higher, the latency is lower. So for the shorter distance we can send the data very fast. If the distance increases, the latency increases. Sorry, if the bandwidth decreases, latency increases. Okay, then there are again various communication protocols, like we have the wireless communication protocols also. We have LoRa, we have Sigfox, okay, then we have Mbus, okay, then we are nowadays the 5G is also we are trying to implement in the IoT kind of a thing for communication for the distance, okay, from you can say 1 kilometer to 10 kilometer in the range of that one. So again, if you are using for LoRa and all, we require some kind of a servers and all we need to implement and all at every 10 kilometers. So again, that is facing issues for that one. And maybe in the future, the satellite communication may be also possible for an IoT application, so that we can manage or we can control the device from anywhere from the world. So that may be the future, you can say. So this is one IoT connectivity, and we have something called as AIoT. Okay, it is nothing but the combination of you can say Internet of Things and AI. It's like AI plus IoT is equals to AIoT. So here we know that we are using the IoT data for collecting the data and exchanging the data and all. But here whatever the algorithms which we are applying, so that directly we are not applying with the help of some kind of a microcontrollers or any other things. So that we are going to communicate, or that we are going to manage with help of artificial intelligence. And at the starting itself I said, like, we are in the industrial revolution 4.0, where embedded system, IoT, and artificial intelligence are depending upon each other. Nowadays we require like we know that we have the IoT as well, but for IoT we require the huge data. So this huge data can be collected from the IoT devices. Okay, so this data can be maybe gone through some kind of a platform, then it will maybe applying for the artificial intelligence networks, like we have the natural processing language and all. Okay, so here some kind of algorithm may be applied, and that maybe the you can say like our machines will become more intelligent than previous. Okay, So if you want, if I give an example, so I am having the home automation. Okay, I'll be having the home automation, and the person who are available in the at a night time. Okay, at a night time, the people who are present in the home at that time, the lamp should be turned on. Okay, and if the people are not available in the home, and if I forgot to off the light using the IoT, so my artificial network, that is nothing but AIoT, can help us to to minimize such kind of this one losses. Okay, instead of turning on that light when no one is there, my AI network can off that light automatically. So depending upon the number of people present inside the room, if no one is there, automatically with the help of AI we can uh, off the lights. So here you can say we are making the AI successful with the help of IoT kind of a data. We are providing huge number of data to the artificial intelligence and all. Okay, so here, like you can say, the deployment will be done from the IoT side. Then data processing will be done from the platform like clouds, different clouds, and which will be going for the artificial networks and all. Then discovery is nothing but like the end users. So this is the future of, you can say, IoT. So then we have the another, you can say, future technology, that is nothing but the wearable IoT technology. So here everything is like, you can say, wireless. Then here are the few applications of IoT. You can say like smart home is there. Then you can see the wearable watches, the smart cities, smart grid, industrial IoT, which I already discussed at the initial part of this IoT. Then connected cars, then health systems, then retail systems, smart supply chains, smart farming. So these are the few areas of the like applications of the IoT. So there may be the many more. Okay. Here, I'll just try to show one demonstration on the smart IoT. So, when you talk about the smart home automation, so like when you talk about only about IoT, so I'll be not considering here AI and all. So, when you talk about like the smart IoT, we'll be having the various peripherals which are connected to the home, whether maybe it may be your room bulbs, whether it may be the AC, or whether it may be the motion detector, okay, which may be placed at your door if someone is available. So it will be intimate you like there is someone at the door who is waiting for you and all. Okay, now here, now we can say now it is the night time. Okay, now it is the night time, and if I want to on the light, okay, with the help of IoT, so I can on the lights. Okay, the light will be on, and in the you can say in the night time the temperature decreases. So maybe the temperature decreases, the humidity also decreases. So we no need of AC. So according to that, according to the algorithm, we can off the AC. Okay, then in the night time, so in the daytime, if the lights are on, so we can make it off. We can turn the lights off. Okay, such kind of home appliances we can control. And in the daytime, if suppose the temperature goes high, we can turn on the AC. Okay, so such kind of applications we can control. Okay, now here how to create this model using embedded systems. Okay, so that will be the one task, you can say. So here first thing is we need to control this kind of applications. Then we require some kind of a microcontroller. Okay, and when you're talking about the microcontroller, I already discussed like how to choose a microcontroller for your embedded application as well as the IoT applications. So we require, you can say, the microcontroller which is having the onboard peripherals like ADC is there, then PWM is there, or whether it is a GPIO, whether it is a timers, etc., etc. So we need to look into that one. I need to configure a microcontroller. Or we need to choose a microcontroller. Now here, so I'll be taking a processor. Okay, now I want to control three kind of applications or three kind of this one. So I'll be taking the sensors. To control the sensors, I require the analog to digital converter. I will look into that one, whether the ADC is available or not. So I'll be selecting an, I'll be configuring an sensor to the ADC. Then I'll be using the motors. Okay, that can be controlled with the help of, you can say, pulse width modulations. So we can increase the speed of the motor or decrease the speed of a motor, or something like that we can do. Then we have the lamps as well. So these lamps can be controlled with the help of you can say pulse width modulation as well as the general purpose input output. So here maybe the intermediate relays and all requires to control the 230 volt appliances and So I'll just show you one demonstration to how to control a 230-volt appliances, okay, with the microcontroller. And so connectivity is one of the main part, you can say, like if you want to connect it to the cloud, or if you want to connect it to any other applications, how you are going to connect it. Okay, so that is one important part. So here I can take Wi-Fi, I can take Bluetooth, I can take LoRa or any other communication protocol I can take, so that I can communicate with the cloud. Okay, and so that I can control it from anywhere in the world. You can say, if I want to, control using the mobile phone dashboard, I can go for phone dashboard. If I want to go for, web dashboard, so I can go for web dashboard as well. If you are going for the networking protocol like HTTP, UDP, or MQTT, so with that also you can able to control. So here I'll be making use of one cloud called as Blink Cloud. So I'll be controlling our, 230-volt appliances using this particular module. So I'll just show the kit whichever I am going to use now. Yeah. So I'll be using a kit, something called as IoT for you, which is manufactured by the Edgate Technologies. Okay, and we have designed this kit in such a way that it should be used for IoT kind of application, and not only for IoT applications. You can say we have framed this kit in such a way that you can use for embedded applications, you can use for IoT applications, and a few AI applications also you can run. In that, in that particular point of view, we have designed this particular board. Okay, and we have made sure like various standard IoT framework should be available, or you can say various standard protocols for IoT should be available on the board. So we have included, you can say, the LoRa module we have included, the Bluetooth module we have included, then Wi-Fi we have included. Okay, then for the future technologies like IoT, that is NB IoT, which is based upon 5G. So we have provision for NB IoT as well. Then other standard protocols for embedded applications also we have included, like you can say I2C we have, then SPI, UART, CAN, then RS232, RS485, such kind of standard communications protocol also we have included on the board. Then this is how the our board looks like. So we have the name of this particular board, we have given it as IoT for you, and which consisting of four different kind of microcontrollers. Okay, like we have started with Arduino Uno. Okay, then we have Raspberry Pi, ESP32, and STM32 Blue Pill. So if someone wants to start with this particular board, so they can start with basics to advanced level, the industrial level, you can say. So the basic level, like how the devices will work or how the peripheral will work. So they can either configure the Arduino Uno, Arduino Uno. They can configure with the simple programming language. You can say like Arduino, Arduino script they can use. Okay, once they understand how the devices will work and what are the things to be configured, so then they can switch for something called as a Raspberry Pi Pico. So here they can go for the Python programming language. Okay, so there is one good advantage here. The Python programming they can learn here, and here the programming language used for Raspberry Pi Pico is nothing but the Micro Python we consider it as. So that programming language we can use here to control this kit. Then we have given the provision for ESP32 as well. So here you can say which is having the various good features like Wi-Fi is available, then Bluetooth is available, so you can communicate with the cloud as well. Then here also you can use the various programming. Okay, so you can go for uh, MicroPython also you can go, I guess, for ESP32 as well as the Arduino script also you can give. And one more thing is upgradability is also there for these microcontrollers. Okay, like you can go for real-time operating system, which is the advanced concept. So you can do with the help of ESP32, or you can go for STM Bluepill. So STM Bluepill you can see the advanced tool. You can learn industrial level programming for STM32 Bluepill. Okay, which is based upon HCL kind of a programming. Or else if you don't want to go for industrial level kind of a programming, then you can go for normal Arduino script programming language as well. Okay, then here apart from that, like we have given the provisional for so here you can see we have given here provisional for Raspberry Pi 3 or 4. Okay, suppose if you are having Raspberry Pi 3 or 4 with you, So you can plug that Raspberry Pi 3 or 4 with help of cable here, and you can use this board. So that provisional also we have given. And apart from that, like we have different sensors like accelerometer and gyroscope sensor we are having. Then we are having here DHT11 sensor we are having. Okay, then potentiometer we have included here. Okay, so just to understand how to interface these analog devices with the help of microcontrollers and all, and to here we have included two, you can say, RGB LED we have included, then two switches we have included here, then two relays which we have included so that you can control your 230-volt appliances with the help of this relays. Then we have also included here potentiometer. Again, this is a you can say analog devices. Buzzer we have included, and here you can see we have included communication protocols like RS-232 we have used here, RS-485, then CAN module we have used. And here there is one more good connectivity which we are giving here, that is the LoRa module with the antenna, you can say. So you can use these devices or control these devices from 10-kilometer distance as well. Okay. So you can say in the rural area you can control from the 10 kilometers, and maybe in the urban it may be varying because signal diffraction and all will be happening. Okay, and here we have given the GSM module as well. Okay, and if you see here, we have given the provision for the NB IoT, which is based upon the 5G. So once the 5G will start working in India, so you can place the Zigbee module or NB IoT module here. So we have given here provision to, okay, this one also. So you need to purchase the separate NB IoT module here and just fix on this one. So it will be supporting for this particular board. So in that particular, you can say this one, we have developed this particular board, which you can use for IoT. So softwares and programming language which can be used is like you can go for Arduino IDE for, you can say, all the microcontrollers except Pico, that is Raspberry Pi Pico. For Raspberry Pi Pico, you can go for Tony IDE. And if you are going to use for STM32, you can either switch for Arduino IDE or you can go for STM32 IDE as well. And MicroPython is also supportable for, you can say, STM32. Then here programming languages, you can say we have embedded C programming language, then Python programming language, and HL programming language for your STM32 controller. So if you guys have any kind of queries, you can just let me know. So I'll just show one demonstration on how to control your devices or control your 230-volt appliances using this particular board.
Thank you, sir. Very nice session. Discussed about various embedded systems and components related to embedded systems, how to select different microcontrollers, microprocessors, and the importance of IoT, different embedded boards like Raspberry Pi, different boards, and what are the programming languages we have to use, which supports the embedded boards. All this explained very nicely, sir. And different applications are also shown. Thank you, sir. And
Yes.
other faculty members, I request if you have any doubts, can clear the doubts.
Hello.
Sir,
Hello. Yes, sir.
demonstration.
Okay, so one application I'll be showing how to control this device using IoT. Okay, so I'll just start sharing my. I've started sharing my screen so that you can see. I have created one. I'm making a demonstration of this particular device.
Yes, sir, the screen is visible.
Yes, sir. Both are visible.
Okay. So you can see in my web page. So I have created one. You can say one widget I've created here in my dashboard. So when I on this, okay, and I'll be using here ESP32 module here, so which is connected for the Wi-Fi. Okay, and here if I just I'll just turn on this particular switch. So the lamp I have connected here, the 230-volt lamp. Okay, so with the help of some relays, I have interfaced it. So if I just press it on, so you can see the 230-volt lamp is on my device. So if I just off this one, you can see the lamp is off in my the lamp is turning off. So here, as of demonstration, have connected only the lamp. So you can control any 230-volt appliances. Okay, if you want to control your television, you can control using IoT. If you want to control the fan, you can control, or any other 230-volt appliances, you can control using this particular kits. If you guys have any kind of a queries, you can feel free to ask.
Dear faculty members, any doubts? Yes, sir. Thank you, sir. I think nobody is having any doubts. And the presentation is very clear, sir. Thank you for the demonstration also.
Yes, sir.
I request HOD sir to speak.
Thank you very much, sir, for your enlightened lecture, and this is nicely presented in terms of IoT as well as embedded processor. Starting from fundamentals, you have thrown some light in every part of embedded processor and basic building blocks of embedded processor. Next, IoT and sensing the signals, and now smart home and smart cities. Everything. Included in this, and the basic IoT for you board also useful, and in near future we are trying our level best to establish this kind of laboratory under R&D and other avenues, sir. And we have been very impressed, and based on your inputs, we will try to organize a physical workshop in near future, sir. Thank you very much.
Yes, sir. Thank you. Thank you, sir.
Okay, if no other doubts, we can present vote of thanks. Concerned authorities, concerned in charges.
Yes, sir.
Or let everybody should switch on camera. The video camera is a problem I had. So take a snapshot for record purpose.
Yes, sir. So, I thank Kushal Nesarkar sir and all other faculties. Thank you, sir. Thank you, everyone.